Hello everyone, today let's solve the three-sum problem. Given an array nums of integer, and we have to find out three numbers that sums out to 0. In order to solve this problem, the first thing we have to do is to sort a string, sort the integers, okay? And I will explain later why we do it. Okay? Sort integer. And then, for example, in this case, after the sorting, we will have these integers. And then we have to iterate through this integer, or just run through these integers. So we will have 3 pointers, current, left, and right. Okay. And the left is always current plus 1. The right is always the last one. So left is always current plus 1, and the right is always the last one. And then we have to check out, as long as the left is smaller than right, we can check out the sum. We can check out sum. So with sum here, and -4 plus -1 plus 2 equals -3. So it's smaller than 0. So since we have the sorted integers, that's the benefit. We know that it's smaller than 0, so we just need to move the left. So we might have potential to have a bigger sum, right? So as long as our sum is smaller than 0, we just left plus plus. So left plus plus is the same, right? Left plus plus. It's -2, -1. And it's in the end, so we have to increment our current pointer and check out again. And -1 plus 2 equals to 0. So 0 equals to, that's what we want, right? So we just add the answer. And then we have to remember that because we don't want to duplicate, so we have to increment the left and decrement the right. And that's our another answer, right? So we just keep doing this. If this is our answer, we just add to our answer, and increment the right, increment the left, and decrement the right. And it's no longer satisfy this condition, so we just move the right, move the current pointer, right? And here's the tricky part is that, as you can see, we have duplicate current pointer. We might have duplicate, right? In this case, if right come to here, we will have another -1, 0, 1. Right? So in order to solve the duplicate problem, we have to check for 3 pointers. As long as for the current pointer, if the current one is the same as previous one, we have to keep increment this. And for the left pointer, it's the same logic. And for the right pointer, because it comes from the right. So as long as the current one is the same as the previous one, we just keep decrement the right pointer. So the edge cases, we have to also to the most important part here is to remove the duplicate. So that's a very important part, and after that we were able to solve this question. So let's see the code in action, so you will have a better understanding. So let's have the create a result. It's a empty result, and then as long as the input is nil, or the length of the nums is equals to 0, we just return the empty result. Do something and return the result, right? And what we should do, we should loop through the array, right? So for the current, start from 0, and the current is smaller than nums and plus plus. Oh, I forgot we have to sort the array first. So sort the nums first, and the left, right? We have to have the left and right pointer, right? Left and right. Left is always z plus 1, current pointer plus 1, and the left is always the last index. Right? And as long as the left is smaller than right, we will check the sum, right? So sum equals to nums current plus nums left plus nums right, right? So if the sum is smaller than 0 here, we have to increment the left, right? Since it's a sorted array, so we might potentially have a bigger sum. So if the sum, else if the sum is bigger than 0, we have to decrement the right, right? So we have potentially have a smaller sum. Else means that we have the answer. So we just add the answer. It's a num current nums left plus nums right, right? Okay, and here's the tricky part, is that we have to remove duplicates for both current left and right. So also, I forgot here. As long as we add an answer, we have to increment, right? Increment the left and decrement the right. Increment the left and decrement the right. And here we have to remove the duplicate for left and right, and in here we have to remove the duplicate for current, right? So for the current, as long as it's not, the index not start from 0 and the previous one, or we can say that the current one is the same as the previous one, right? We just continue, right? So like this example, so C goes from index 1 to index 2, but it's the same as the previous one, right? So we keep increment this. So that's how we handle the current. And for the left and right is almost the same. So we have to also check the condition, right? So for as long as the left is smaller than right, and we have to check out whether or not the left is the same as his previous one, right? So nums left is the same as his previous one. We have to keep increment the left. And for the right is the same. As long as the right is the same as its previous one, we have to decrement the right, right? And that's how we solve the duplicate part. And for the time complexity for this algorithm is square, and the space complexity is O1. Yn squared, because each time we not only loop through for the current index, we not only from the beginning to the end, right? We also have to loop through the left, right? We have to also for the sub array, we also have to move to check each condition, right? So for each current index, we have to check the sub indexes. So the time complexity is O squared, On squared. Let's see the answer. We don't know it's correct. Okay, let's submit. Yeah, that's it. So thank you for watching.